Chapter 1: The Echoes of Tomorrow. Welcome to Synapse Daily. Today, we step back into a world that no longer exists, a world where the future wasn't a threat, but a shiny, plastic promise. Close your eyes and imagine the year 1957. The post-war boom is in full swing. Television is still a miracle, and the space race is just beginning to ignite the collective imagination of humanity. The air in California smells of a peculiar mix: the salt of the Pacific, the optimism of the American dream, and the faint, ozone-like scent of new chemistry. In the heart of this era's innovation, a structure rose that defied every law of traditional architecture. It didn't belong to the world of wood, brick, or stone. It was a bold, synthetic manifesto. This was the Phillips House of the future, more famously known through its partnership with Monsanto. It stood as a beacon of what was possible when the laboratory met the living room. For the average family in 1957, this wasn't just a house, it was a spaceship that had decided to dock in the suburbs. It represented a vision of 1986, delivered nearly 30 years ahead of schedule. At that time, 1986 felt like a distant, utopian century. People believed that by then, we would have conquered all of nature's inconveniences. No more termites, no more rotting wood, no more peeling paint. But as we sit here in the present, we know that every dream has an expiration date. In 1977, that date arrived for this plastic marvel. What was supposed to be a routine demolition turned into one of the most bizarre battles in construction history. It was a literal war between man-made machines and a material that simply refused to surrender. How did we build something so resilient that we ended up fearing our own creation? Why did a vision that looked so bright in the 50s end up being choked by steel cables 20 years later? As we dive into the plastic heart of 1977, we aren't just looking at a building, we are looking at the moment humanity realized that forever is a very long time to live with a mistake. Chapter 2: The Birth of a Synthetic Dream. To understand the violent end of this house, we must first understand the fanatical ambition behind its birth. This wasn't a project born in a typical architect's office. It was a high-stakes collaboration between the titans of industry and the sharpest minds in academia. The Massachusetts Institute of Technology, MIT, provided the engineering genius, while Monsanto, the chemical giant, provided the raw material, reinforced polyester. They wanted to solve the housing crisis of the post-war era by turning home construction into something more akin to car manufacturing. The design was a radical cruciform. Imagine a central square core, but instead of walls reaching the ground, four massive wings stretched out into the air, cantilevered and floating above the earth. It looked like a giant, four-petaled white flower made of fiberglass. When it opened at Disneyland's Tomorrowland, it became an overnight sensation. Thousands of people stood in line for hours just to catch a glimpse of a kitchen that didn't have a stove. They saw ultrasonic dishwashers and microwave ovens at a time when most people still used iceboxes and cold-heated water. The walls weren't just walls, they were curved shells of polyester resin, reinforced with millions of glass fibers. This combination created a strength-to-weight ratio that was practically unheard of in residential building. The architects, Richard Hamilton and Marvin Goody, weren't just building a house, they were testing a theory. They believed that the home of the future should be modular. If a family grew, you simply bolted on another plastic wing. It was a Lego-like dream of efficiency. But the industry wasn't ready. The world was built on hammers, nails, and the sweat of carpenters. The Phillips house represented a world where chemistry did the work. It was a miracle of engineering that would eventually become a nightmare of disposal. We were looking at a future that was physically superior to the present, yet socially and economically isolated. Chapter 3: Life Inside the Plastic Shell. What was it actually like to stand inside a house that felt like a submarine? The interior was a masterpiece of mid-century modernism, but it felt different. Every corner was rounded. There were no sharp edges where dust could hide. Everything was integrated. The furniture wasn't something you bought and moved in, it was molded directly into the structure. The beds, the tables, the seating, it was all part of the house's DNA. The windows were massive, panoramic sheets of acrylic that offered a distorted but fascinating view of the outside world. Visitors often described a sense of sterile safety. There was a profound quietness inside those plastic walls. The house was termite-proof, rot-proof, and almost entirely weatherproof. It didn't breathe like a wooden house. It didn't creak when the wind blew. It stood silent and immovable. The kitchen, dubbed the Atoms for Living kitchen, was the crown jewel. It featured disappearing shelves that lowered from the ceiling at the touch of a button. The bathrooms were single, seamless molded units. Imagine a world with no tiles, no grout to scrub, and no leaks. It was the ultimate damp cloth lifestyle. But as the years went by, the psychological weight of living in a synthetic bubble began to surface. While the house was physically perfect, it felt detached from the earth. There was no patina of age. The plastic didn't grow old gracefully, it just stayed the same, unchanging, and cold. A question began to grow in the minds of the planners: if this material is truly permanent, what happens when our tastes change? If we can't renovate a house because its walls are as hard as a diamond, do we become prisoners of our own design? By the mid-70s, the future started to look like a plastic cage. The very qualities that made it a miracle, its durability and its resistance to the elements, were becoming its greatest flaws. Chapter 4: The 1977 Ultimatum. By the time 1977 rolled around, the House of the Future had become a nostalgic relic. It had stood for 20 years, and in the fast-paced world of theme parks and technology, 20 years is an eternity. Over 20 million people had walked through its plastic halls. The lease with Disneyland was ending, and the land was desperately needed for New Tomorrowland and the upcoming Space Mountain. The decision was made with a simple stroke of a pen: the house must go. On a crisp, sunny morning in late 1977, the demolition crews arrived. They were relaxed, even joking. In their minds, they were there to tear down a plastic toy. They brought the standard tools of destruction: a massive crane equipped with a 3,000-pound steel wrecking ball. The operator positioned the crane, the crowd gathered behind the safety ropes, and the first swing was initiated. The ball accelerated through the air, aiming for the center of one of the cantilevered wings. The sound was a dull, echoing thud that resonated through the park. But when the dust settled, the crowd gasped. The wrecking ball hadn't smashed the wall. It had bounced. Like a tennis ball hitting a garage door, the 1.5-ton steel sphere had struck the polyester shell and flown backward with terrifying force. The house didn't shatter. It didn't even crack. It simply absorbed the kinetic energy and flexed. The operator, stunned, tried again with more momentum. Again, the ball bounced. The future was not going quietly into the night. It was as if the house was asserting its dominance over the machines of the present. This was the beginning of a multi-day standoff that would humiliate the demolition team and prove that the engineers of 1957 had succeeded far too well. Chapter 5: Man vs. Material. The failure of the wrecking ball wasn't just a technical glitch, it was a blow to the ego of 1970s industrial power. The demolition crew was baffled. They had brought down reinforced concrete parking lots and steel frame buildings with less effort. After the first few bounces, the atmosphere on the site changed from a routine job to a desperate siege. The crane operator tried a new tactic. Instead of swinging, he dropped the ball from a massive height directly onto the roof. Again, the result was the same. The fiberglass reinforced polyester, FRP, acted like a giant, rigid trampoline. The energy of the impact traveled through the curved geometry of the house and dissipated into the ground. The crew grew frustrated. They called for heavier reinforcement. They brought in industrial-grade jackhammers, the kind used to pierce through granite. But as the bits touched the white surface of the house, they didn't penetrate. They slipped. The polyester resin was so smooth and so hard that the mechanical tips couldn't find a bite. When they finally managed to stabilize a jackhammer, the vibration was so intense that it nearly shook the workers' bones apart, yet the plastic only showed a few surface scratches. Then came the torches. If we can't break it, we'll melt it, they thought. But the MIT engineers had prepared for this too. The material was impregnated with flame retardants. As the blue flames of the oxyacetylene torches licked the walls, a house didn't melt like a plastic cup. It charred. It turned black and released a thick, acrid smoke that made it impossible for the workers to breathe, even with masks. The material was essentially curing further under the heat. The onlookers began to laugh. News crews arrived. The headline was clear: the house of the future was mocking the present. It was a moment where the world realized that human ingenuity can sometimes create things that are too perfect for our own control. Chapter 6: The Secret of Fiberglass Strength. To understand why the Phillips house was winning this war, we have to look at its microscopic architecture. This wasn't just plastic in the way we think of a soda bottle. This was a sophisticated composite. In 1957, the engineers at Monsanto and MIT didn't just pour chemicals into a mold. They handlaid thousands of layers of woven glass fibers, each layer saturated with high-grade polyester resin. Think of it like a suit of armor made of millions of microscopic glass swords held together by a chemical glue that becomes harder over time. Over its 20-year lifespan, the house had been exposed to the intense California sun. Normally, UV rays destroy plastics. But this specific composite had gone through a process called post-curing. The heat from the sun had actually caused the chemical bonds to tighten even further. By 1977, the house was significantly stronger than the day it was built. It had become a monolithic shell, a single, continuous piece of matter. In a traditional house, you have joints. You have nails, bolts, and seams where one material meets another. These are the fault lines that a demolition crew exploits. But the Phillips house had no joints. The wings were chemically bonded to the core. To break a wing, you had to overcome the molecular tension of the entire structure. It was a masterclass in structural integrity that defied the disposable culture of the late 70s. The engineers had designed it to withstand the foot traffic of millions and the potential of earthquakes. They had succeeded so well that they had inadvertently created a structure that was virtually immortal by 1970s standards. Chapter 7: The Choker Chains. After several days of public humiliation, the demolition company realized they needed to stop trying to break the house and start trying to strangle it. They abandoned the brute force of the wrecking ball and brought in the choker chains. These were massive, industrial-strength steel cables designed to pull down skyscrapers and bridge pylons. The plan was to wrap these cables around the floating wings of the house and use the raw power of heavy-duty tractors to squeeze the structure until it imploded. As the tractors moved into position, the sound of the engines filled the park. The cables tightened. This was the most dramatic moment of the entire process. The crowd went silent. You could hear the material beginning to protest. It wasn't the sound of wood snapping, it was a high-pitched, metallic singing as the glass fibers began to tension. It sounded like a giant violin string about to snap. The groaning of the plastic was eerie, a sound that many witnesses described as painful to hear. It felt as if the house was a living creature being tortured. Suddenly, a sound like a cannon shot rang out. But it wasn't the plastic breaking. It was the massive steel bolts that anchored the house to its concrete foundation. They had snapped under the pressure. The house, still entirely intact, was ripped clean off its base. Even then, the plastic wings didn't shatter. The house sat there, lopsided but whole, like a fallen spaceship. It took another several days of strangling the wings with the cables before the first major structural failure occurred. The house finally began to collapse inward, but even in its death throes, it broke into huge, jagged chunks that were as sharp as razors and nearly impossible to move. Chapter 8: Environmental Aftermath. When the Phillips house was finally reduced to a pile of white shards, the victory felt hollow. The demolition had taken weeks instead of days. It had cost thousands more than budgeted. But the real problem was just beginning. What do you do with 10,000 pounds of indestructible synthetic rubble? In 1977, the Green Movement was in its infancy, but the environmental reality of this house was a wake-up call for everyone involved. The shards were a logistical nightmare. You couldn't burn them, the toxic fumes were a public health hazard. You couldn't recycle them, the technology to separate glass fibers from polyester resin didn't exist in a cost-effective way. And you certainly couldn't just leave them there. The material was biologically inert. It wouldn't rot. It wouldn't attract bacteria. It wouldn't provide nutrients to the soil. If you buried it, it would stay in the ground, unchanged, for 1,000 years. This was the first time the public really grasped the dark side of the plastic age. We had created a material that was too good at existing. The shards of the Phillips house were eventually hauled away to a landfill in California. Somewhere, deep beneath layers of earth, those white panels are still there. They are as strong and as white as they were the day the wrecking ball bounced off them. This demolition proved that while humanity is excellent at imagining the future, we are often dangerously short-sighted about how to clean it up. The Phillips house became a symbol of the plastic trap, a material designed for convenience that became a permanent burden on the planet. Chapter 9: The Legacy of Innovation. The dust from the demolition eventually settled, but the intellectual impact of the Phillips house remained suspended in the air. While the physical structure was gone, its DNA had already begun to replicate in every corner of the modern world. We often look at failed experiments as dead ends, but in the world of high-stakes engineering, there is no such thing as a total failure. The Phillips house was a prototype not just for a home, but for a philosophy of living. It taught us that the machine for living, a concept popularized by Le Corbusier, was actually possible, even if the public wasn't quite ready for the sterile reality of it. Think about your life today. When you look at a modern smartphone, you are looking at the direct descendant of the Phillips house's design philosophy, integration. The house taught architects that heating, lighting, and communication shouldn't be add-ons to a building, they should be part of its skeletal structure. The zone climate control that we now take for granted in smart homes was pioneered in those plastic wings. The idea of the microwave, a device that seemed like sorcery to the 1957 housewife, became a staple of every kitchen on Earth. The Phillips house also changed the way we think about materials. It proved that composites, the marriage of glass and resin, could be stronger than steel. Today, this technology isn't used to build our houses, but it is used to build the wings of the Boeing 787 Dreamliner and the hulls of high-performance yachts. The house died in 1977 so that modern aerospace and automotive engineering could live. It was a sacrifice of a single building for the advancement of an entire branch of material science. We might not live in plastic boxes, but we live in a world built by the data gathered from that house's 20-year existence. Chapter 10: The Forgotten Twin. One of the most fascinating aspects of the House of the Future is that it wasn't an isolated incident. It was part of a global movement, a polymer fever that gripped the world from the late 50s to the early 70s. While the Phillips house in Anaheim was the most famous, it had cousins all over the globe. Perhaps the most striking was the Futuro house, designed by Finnish architect Matti Saarinen in 1968. If the Phillips house was a flower, the Futuro was a literal UFO, a round, elliptical pod on stilts, made of the same fiberglass reinforced plastic. These structures popped up in the most unlikely places: the mountains of Taiwan, the suburbs of New Jersey, and the forests of Finland. They were marketed as portable ski chalets or weekend getaways. But they all faced the same 1977 problem. They were incredibly difficult to maintain and even harder to destroy. Today, these alien houses sit like forgotten fossils in the landscape. Some have been converted into quirky cafes, others are rotting hulks that local councils are afraid to touch because the cost of demolition is too high. The Phillips house was the celebrity of this movement, the one that had the most eyes on it. Its violent end in 1977 marked the official psychological end of space-age optimism. When the wrecking ball finally won, it wasn't just breaking plastic, it was breaking the idea that technology could solve every human problem. We stopped dreaming of plastic cities and started worrying about the energy crisis and the long-term effects of synthetic chemicals. The twins of the Phillips house that still stand today serve as haunting reminders of a future that we started to build but were too afraid to inhabit. Chapter 11: Psychological Impact on the Public. The Battle of 1977 wasn't just an engineering struggle, it was a cultural spectacle. For the millions of people who had visited the house, seeing it refuse to crumble under the wrecking ball felt deeply symbolic. You have to remember the context of the late 1970s. America was going through a crisis of confidence. The Vietnam War had ended in heartbreak, the Watergate scandal had shattered trust in institutions, and the economy was staggering under inflation. In this world of crumbling values, the the 1950s house stood as an unbreakable monolith. Witnesses at the park in 1977 reported a strange mix of emotions. There was a sense of cheering for the house. People wanted the plastic to win. Every time the wrecking ball bounced off, the crowd cheered. Why? Because the house represented a time when we were sure of ourselves. It represented a time when the future was a place we wanted to go, not a catastrophe we were trying to avoid. A house's defiance was a physical manifestation of a lost era's strength. When the house was finally torn apart, it felt like the final nail in the coffin of the mid-century dream. The demolition became a spectacle of irony. We had spent 20 years inviting people to step into the future, only to spend the 21st year showing them how hard it is to kill that same future. It forced a generation to confront their own fickleness. We realized that our desire for the new is often accompanied by a total lack of respect for the permanent. The psychological scar left by the demolition of the Phillips house helped shift the architectural world back toward natural materials, wood, stone, and brick, things that we understood how to build, and more importantly, how to bury. Chapter 12, Lessons for the 21st Century. As we stand in the 2020s, the story of the 1977 demolition feels more relevant than ever. We are currently in the midst of a new technological revolution. We are building smart cities, 3D printing houses from concrete, and filling our homes with Internet of Things devices that will be obsolete in 36 months. We are, once again, obsessed with the future. But are we asking the right questions? The Phillips house reminds us that durability without flexibility is a trap. If you build a house that is indestructible, you better be sure that the design is perfect for the next 1,000 years. In our current era of fast fashion and fast tech, we have gone to the opposite extreme. We build things to break. We build things to be replaced. But the Phillips house shows us the middle ground we missed. We need materials that are strong, yes, but we also need a circular economy. We need to know how a building will die before we even dig the foundation. Today's architects are looking back at the 1977 disaster as a lesson in design for disassembly. We are learning to create structures that can be taken apart as easily as they are put together. The failure of the Phillips house demolition wasn't that the material was too strong, it was that the design didn't account for its own exit strategy. As we move toward a more sustainable world, we must remember the white shards in that California landfill. They are a warning. Humanity's greatest challenge isn't just creating the future, it's managing the remnants of the dreams we outgrow. Chapter 13, Closing the Circle. As we conclude this deep dive on Synapse Daily, take a moment to look around you. The ghost of the Phillips house is closer than you think. It's in the insulation in your attic. It's in the PVC pipes that carry your water. It's in the sleek, rounded edges of your laptop. The future didn't arrive in the form of a white fiberglass flower in 1986, but its essence survived the wrecking ball. It didn't die in 1977, it just dispersed. It broke into 1,000,000 pieces and integrated into the very fabric of our modern existence. The 1977 demolition was a brutal end to a beautiful dream, but it was also a necessary awakening. It taught us about the permanence of our choices. It showed us that when we build, we are not just creating shelter, we are leaving a mark on the planet that may outlast our civilizations. The house that wouldn't die finally fell, but only after it had proved its point. It proved that we are capable of extraordinary things, but it also warned us to be careful with the miracles we create in the lab. The next time you see a construction site or a new technological marvel, remember the day the wrecking ball bounced. Remember the high-pitched scream of the plastic under the choker chains. Remember that the future is something we build every day, but it's also something we eventually have to live with. Thank you for joining us on this journey through the plastic heart of 1977. Stay curious, stay grounded, and always remember, the future is only as good as our ability to handle its legacy. This has been Synapse Daily. We'll see you tomorrow, in the world we're building right now.